Hello all, welcome back to our channel. Today we are going to discuss about our new topic complex number, which is chapter 9. This is chapter 9. Already chapter 8 has discussed in the previous class. First of all, let us see the definition of a complex number. An expression of the form x plus iy. Any expression of the form x plus iy where x and y are real numbers. X and y are real numbers and I square is equal to minus 1 is called a complex number. So the definition of a complex number is an expression of the form x plus iy where x and y are real numbers and I square equal to minus 1 is said to be a complex number. Here x is called real part and y is called imaginary part. So I లేని పార్ట్ ఏదైతే ఉందో అది రియల్ పార్ట్. సో హియర్ ఎక్స్ ఈస్ రియల్ పార్ట్. ఐ ఉన్న పార్ట్ ఎవరు అంటే వై. సో వై ఈస్ ఇమాజినరీ పార్ట్. So here in a complex number we have two parts where x is a real part, y is a imaginary part. Therefore real part can be denoted by r of x. Next imaginary part is denoted by I of x plus iy. Here also x plus iy. R ante real part of x plus iy is x. I ante imaginary part of x plus iy is y. For example, 2 plus 3i is a complex number. Minus 1 plus I is a complex number. Root 2 plus I is a complex number. 2 minus I root 3 is also a complex number and so on. So like this, the set of all complex numbers is denoted by capital C. Set of all complex numbers is denoted by capital C. Therefore, the set builder form of complex numbers is where set opens x plus iy such that x comma y belongs to real numbers and I square is equal to minus 1. So this is known as set builder form of complex numbers set. Here R is said to be real numbers. This R and this R is different. This is real numbers, this is real part. A complex number may also be defined as an ordered pair of real numbers and it is denoted by the symbol x comma y where it is equal to z. Every complex number is denoted with the letter z. Here x is called real part and y is called imaginary part. And I of z is called a complex number z. So thus any complex number z is equal to x plus iy is also denoted by z is equal to ordered pair of x comma y where I square equal to minus 1. Now let us discuss algebra of complex numbers. Two complex numbers z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2 are said to be equal when real part of z1 is equal to real part of z2 and imaginary part of z1 is equal to imaginary part of z2, that is x1 is equal to x2 and y1 is equal to y2. So if and only if x1 equal to x2 and y1 equal to y2, then only we can say that z1 is equal to z2. That is, any two complex numbers are said to be equal when their real parts are equal and imaginary parts are also equal. Therefore, the two complex numbers are equal if and only if the real and imaginary parts are separately equal. Now let us see the definition of addition, subtraction, multiplication and division of two complex numbers. First of all, let us see the addition of two complex numbers. So here we have taken already z1 and z2 are the two complex numbers. Let us add these z1 and z2. z1 plus z2 is equal to, so here first of all we have to add real part plus imaginary part plus imaginary part, that is x1 plus x2 plus I into y1 plus y2. Now let us see subtraction. Subtraction also, z1 minus z2 is equal to real part minus real part plus imaginary part minus imaginary part, that is x1 minus x2 plus I into y1 minus y2. So this is addition and subtraction. Now let us see the multiplication. Multiplication of two complex numbers z1 into z2 is equal to x1 x2 minus y1 y2 plus I into x1 y2 plus x2 y1. Therefore, the multiplication of two complex numbers is given by x1 x2 minus y1 y2 plus I into x1 y2 plus x2 y1. Now, division. So, the division of two complex numbers is given by z1 divided by z2 is equal to x1 x2 plus y1 y2 plus I into x2 y1 minus x1 y2 by x2 square plus y2 square. Therefore, the division of two complex numbers is x1 x2 plus y1 y2 plus I into x2 y1 minus x1 y2 by x2 square plus y2 square. So these four are algebra of complex numbers where addition, subtraction, multiplication and division has seen. So the sum, difference, product and quotient of any two complex numbers z1 and z2 is itself a complex number. Now let us see some properties of complex numbers. So our first property of complex number is addition of two complex numbers is commutative. So addition is commutative. That is z1 plus z2 is equal to z2 plus z1. Now our second property is addition of two complex numbers is also associative. Addition is associative. Addition of two complex numbers or addition of three complex numbers satisfies associative property. That is z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. So now third property is there exists additive identity. So existence of 0, existence of 0, where 0 is additive identity. That is z plus 0 is equal to 0 plus z is equal to z, where 0 is said to be additive identity. Next, existence of additive inverse. Additive inverse exists. That is z plus of minus z is equal to 0, where minus z is said to be additive inverse of z. Fifth property is multiplication is also commutative property. These four properties are for addition. Now let us see for multiplication. Multiplication of two complex numbers is also commutative. That is z1 into z2 is equal to z2 into z1. Now sixth property is existence of additive identity and also existence of multiplicative identity. Existence of multiplicative identity, that is z into 1 comma 0 is equal to 1 comma 0 into z. Next seventh one, that is z into 1 equal to 1 into z is equal to z. So here 1 is said to be multiplicative identity. Existence of multiplicative inverse. Multiplicative inverse exists. That is z into z inverse is equal to z inverse into z is equal to 1. So here z inverse or 1 by z is said to be multiplicative inverse of z. So these are the 7 properties, and last one is multiplication is associative. That is z1 into z2 into z3 is equal to z1 into z2 into z3. So the z1 into z2 into z3 equal to z1 z2 into z3 is said to be multiplication of associative property. So these are the 8 properties we have for complex numbers. Now let us see some formulae. So our first formula is additive inverse of x plus iy. Is denoted by ai is equal to minus z. So minus of x plus iy. సింప్లీ ఇచ్చిన కాంప్లెక్స్ నెంబర్స్కి మైనస్తో మల్టిప్లై చేస్తే వచ్చే ఆన్సర్ని మనం అడిటివ్ ఇన్వర్స్ అంటాం. సెకండ్ ఫార్ములా ఈస్ మల్టిప్లికేటివ్ ఇన్వర్స్. మల్టిప్లికేటివ్ ఇన్వర్స్ ఆఫ్ z ఈక్వల్ టు x ప్లస్ iy. Multiplicative inverse of z equal to x plus iy is denoted by mi, which is equal to 1 by z, which is equal to, ఇక్కడ ప్లస్ ఉంటే మనం మైనస్ రాయాలి, ఒకవేళ మైనస్ ఉంటే ప్లస్ రాయాలి. సో ఇక్కడ ప్లస్ ఉంది కాబట్టి x మైనస్ iy బై ఎక్స్ స్క్వేర్ ప్లస్ వై స్క్వేర్. సో ఇక్కడ ఎక్స్ మైనస్ ఐవై ఇచ్చారనుకోండి, మనం ఏం రాయాలి? మల్టిప్లికేటివ్ ఇన్వర్స్ అన్నప్పుడు ఎక్స్ ప్లస్ ఐవై బై ఎక్స్ స్క్వేర్ ప్లస్ వై స్క్వేర్. అవర్ నెక్స్ట్ టాపిక్ ఈస్ కాంజుగేట్ ఆఫ్ ఏ కాంప్లెక్స్ నెంబర్. కాంప్లెక్స్ కాంజుగేట్. So this is a 1 mark question. You will be asking the definition of complex conjugate or conjugate of a complex number in your examination of mid or end. So the definition of a complex conjugate or conjugate of a complex number is two complex numbers which differ in the sign of their imaginary parts, then those two numbers are said to be conjugate to each other. That is, if z equal to x plus iy, then x minus iy is said to be a complex conjugate of x plus iy, and conjugate of a complex number is denoted with z bar. దట్ ఈస్ టూ కాంప్లెక్స్ నెంబర్స్ రెండు సేమ్ ఉంటాయి, బట్ దే డిఫర్ ఓన్లీ ఇన్ ద సైన్. ఫస్ట్ నెంబర్లో ప్లస్ ఉంటే దాని కాంజుగేట్లో మైనస్ ఉండాలి, లేదా ఫస్ట్ నెంబర్లో మైనస్ ఉంటే దాని కాంజుగేట్లో ప్లస్ ఉండాలి. ఓన్లీ ఇమాజినరీ పార్ట్లో ఉన్న సింబల్ మాత్రమే డిఫరెంట్ ఉంటే those two numbers are said to be complex numbers which are conjugate to each other. Therefore, z and z bar are said to be conjugate to each other. So the conjugate is denoted by the letter z bar. For example, z equal to 2 plus 3i. Then its complex conjugate is z bar equal to 2 minus 3i. So second example, let us see. Let us z equal to minus 1 minus 2i. So its conjugate z bar equal to minus 1 plus 2i. Only differs in the sign of imaginary part అనేది ఒకటి గుర్తుపెట్టుకోవాలి. ఐ పక్కనున్న సింబల్ మాత్రమే డిఫరెంట్గా రాయాలి. దట్ ఈస్ మైనస్ ఉంటే ప్లస్ రాయాలి, ప్లస్ ఉంటే మైనస్ రాయాలి. రిమైనింగ్ పార్ట్స్లో ఉన్న సింబల్స్ని మార్చొద్దు. లెట్ us take one more example. z equal to 2 minus i. z bar equal to 2 plus i. So like this you have to write the complex conjugate for any complex number. Now let us see the polar form or modulus amplitude form of a complex number, which is very important topic. You'll get one 5 marks question from this topic. So modulus amplitude form or polar form. సో హియర్ మాడ్యులస్ యాంప్లిట్యూడ్ ఫామ్లో మనకి 2 వర్డ్స్ కనిపిస్తున్నాయి. ఫస్ట్ వన్ ఈజ్ మాడ్యులస్, సెకండ్ వన్ ఈజ్ యాంప్లిట్యూడ్. ఫస్ట్ ఆఫ్ ఆల్ లెట్ us see the modulus and amplitude differently. Let z equal to x plus iy is a complex number. Then modulus of this complex number z equal to modulus of z is equal to mod z, which is equal to under root of x square plus y square. Therefore, modulus of any complex number can be found out by using the formula under root of x square plus y square. Next, amplitude of a complex number. Is denoted by theta. Theta equal to tan inverse y by x. Therefore, by using theta equal to tan inverse y by x, we can find out the value of amplitude for a complex number. So thus every complex number x plus iy can always be represented in the form of modulus amplitude form or polar form. That is, modulus amplitude form short form is MAF is equal to R into cos theta plus I sin theta. So here R is known as modulus, theta is known as amplitude. Therefore, the combination of modulus and amplitude is modulus amplitude form or polar form. Therefore, the complex number x plus iy is called Cartesian form of z and r, and it is also known as a polar form or modulus amplitude form. Therefore, r is known as modulus, theta is known as amplitude. Now let us discuss exponential form. exponential form EF is equal to R into, so here R cos theta plus I sin theta can also be written as e power I theta. So R into e power I theta is known as exponential form of complex number z equal to x plus iy. Now let us see some properties of conjugate, modulus and amplitude form of a complex number. Properties of conjugate, modulus and amplitude can also be called as argument of a complex number. So if z1 z2, so our first property is if z comma z1 comma z2 belongs to complex numbers set, then z1 plus z2 bar is equal to z1 bar plus z2 bar. Second one, this is very important for your exam also. Z1 plus z2 whole conjugate is equal to z1 conjugate plus z2 conjugate. So z conjugate whole conjugate is equal to z. సపోజ్ ఎనీ కాంప్లెక్స్ నెంబర్స్కి మనం 2 సార్లు కాంజుగేట్ చేస్తే మళ్ళీ మనకి అదే కాంప్లెక్స్ నెంబర్ వస్తుంది. థర్డ్ వన్ ఈజ్ z1 into z2 whole conjugate is equal to z1 conjugate into z2 conjugate. Addition is multiplication. ఇక్కడ ప్లస్ సింబల్, ఇక్కడ ఇంటూ సింబల్, సేమ్ ప్రాపర్టీ. Similarly, fourth one is z1 minus z2 whole conjugate is equal to z1 conjugate minus z2 conjugate. So addition, subtraction, multiplication. సేమ్ ప్రాపర్టీ ఉంది. ప్లస్ ఉంటే ప్లస్ రాస్తున్నాం, మైనస్ ఉంటే మైనస్ రాస్తున్నాం, ఇంటూ ఉంటే ఇంటూ రాస్తున్నాం. బట్ కాంజుగేట్ మాత్రం సపరేట్ అవుతుంది. అలాగే డివిజన్ కూడా చూద్దాం. ఫిఫ్త్ ప్రాపర్టీ ఈస్ z1 by z2 whole conjugate is equal to z1 conjugate divided by z2 bar. Therefore z1 by z2 whole bar is equal to z1 bar by z2 bar, where z2 bar is not equal to 0. Next, sixth one is mod z bar is equal to mod z. That is, if you do the modulus for any complex number x plus iy, then it will be equal to the modulus of its conjugate x minus iy. And one more important property, seventh one, which is very important, z into z bar is equal to mod z square. Z bar equal to mod z square. Seventh one is z plus z bar is equal to 2 into real part of z, whereas z minus z bar is equal to I into 2 into imaginary part of x. Therefore z plus z bar equal to 2 into real part of x. Z minus z bar is equal to I into 2 times of imaginary part of x. Next, eighth one is mod of z1 by z2 is equal to mod z1 by mod z2. mod అనేది సపరేట్ అవుతుంది అనేది ప్రాపర్టీ. 9th one, mod of z1 into z2 is equal to mod z1 into mod z2. సో మల్టిప్లికేషన్లో కూడా మోడ్ సపరేట్ అయింది, డివిజన్లో కూడా మోడ్ సపరేట్ అయింది. నెక్స్ట్ mod of z1 plus z2 is less than or equal to mod z1 plus mod z2. Next, mod z1 minus z2 is greater than or equal to mod z1 minus mod z2. So this is all about modulus. This is all about conjugate. Now let us see about argument. 12th one is argument of z bar is equal to minus argument of z. Argument or amplitude we can say. So amplitude of z bar is equal to minus amplitude of z. Similarly, amplitude of z1 into z2 is equal to amplitude of z1 plus amplitude or argument of z2. So here multiplication, but it is addition. Next, argument of z1 by z2 is equal to argument of z1 minus argument of z2. దట్ ఈస్ మల్టిప్లికేషన్ వస్తే అడిషన్ వస్తుంది, డివిజన్ వస్తే సబ్స్ట్రాక్షన్ వస్తుంది అని గుర్తుపెట్టుకోవాలి. సో దీస్ 3 ప్రాపర్టీస్ ఫర్ ఆర్గ్యుమెంట్స్ ఆఫ్ కాంప్లెక్స్ నెంబర్. These 3 properties are for modulus of a complex number. And here one more property, mod z bar is equal to mod z. These 4 properties and this one important property, z bar equal to mod z square. These 5 properties comes under modulus of a complex number, and these 5 properties comes under conjugate of a complex number. So these are properties related to conjugate, modulus and arguments of a complex number. Now already we have seen the exponential form of a complex number, but we have e power x expansion as, this is very important expansion, e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x power 3 by 3 factorial plus so on. So in this expansion, let us assume in place of x, put x equal to I into theta. Therefore e power I theta is equal to 1 plus, ఎక్కడ x ఉంటే అక్కడ I thetaని రీప్లేస్ చేయండి, I theta by 1 factorial plus I square theta square by 2 factorial plus I cube theta cube by 3 factorial plus so on. From this I can write I is equal to I only, but I square equal to minus 1. So here you have to identify some values where I square is equal to minus 1, I cube is equal to I square into I. So minus 1 into I minus I power 4 is equal to plus 1, because I square into I square is equal to minus 1 into minus 1 plus 1. Therefore we can write e power I theta is equal to 1 plus I into theta by 1 factorial plus I square is minus 1. So minus 1 into theta square by 2 factorial. Next I cube is minus I. Therefore minus I into theta cube by 3 factorial plus so on. Now we can separate the real parts and imaginary parts from this expansion. Therefore e power I theta can be written as real part is 1 minus theta square by 2 factorial plus theta power 4 by 4 factorial plus so on. Next plus I into, here it is imaginary part, I unna part imaginary antam, I lendi real antam. So I undi evaru theta by 1 factorial. Next minus theta cube by 3 factorial. Next plus theta power 5 by 5 factorial. So on. So here already మనం ఇంతకుముందు ప్రీవియస్ క్లాస్లో డిస్కస్ చేసాం sin x expansion, cos x expansion అనేది. So this is known as cos theta expansion. Therefore e power I theta is equal to cos theta plus I into, this is known as sin theta expansion. Therefore cos theta plus I sin theta. So from this expansion only we have written e power I theta is equal to cos theta plus I sin theta. Therefore the modulus amplitude form converted to exponential form by using this e power I theta expansion. That is exponential form can be written as r into e power I theta, whereas modulus amplitude form is written as r into cos theta plus I sin theta. Now let us see some circular functions of a complex variable. Circular functions of a complex variable. If z is a complex variable or a complex number, we define circular functions of z as follows. That is sin z is equal to e power iz minus e power minus iz by 2i. So in previous class we have discussed about hyperbolic functions. Hyperbolic functions lo manaki sin hx formula e power x minus e power minus x by 2 anundi. Same process lo sin z formula is e power iz minus e power minus iz అంటే ఏంటి x ప్లేస్ లో మనకి z వచ్చింది by 2i. Similarly cos z is equal to e power iz plus e power minus iz by 2, because cos hx expansion is e power x plus e power minus x by 2. Next tan z is equal to sin z by cos z, which is equal to e power iz minus e power minus iz by e power iz plus e power minus iz. Now from these three expansions we can write cot z is equal to 1 by tan z is equal to e power iz plus e power minus iz by, so tan z ఉన్న ఎక్స్పాన్షన్ ని రివర్స్ రాయండి, న్యూమరేటర్ డినామినేటర్కి, డినామినేటర్ న్యూమరేటర్కి, బై ఈ పవర్ iz మైనస్ ఈ పవర్ మైనస్ iz. సిమిలర్లీ sec z is equal to 1 by cos z, because reciprocal of cos is sec. Therefore 2 by e power iz plus e power minus iz. Next cosec z is equal to cosec is reciprocal of sine. So 1 by sine z is equal to 2i by, so ఇక్కడ న్యూమరేటర్ డినామినేటర్కి రాయండి, డినామినేటర్ న్యూమరేటర్కి రాయండి. సింపుల్ ప్రాసెస్. e power iz minus e power minus iz. So these 6, 1, 2, 3, 4, 5, 6. These 6 are circular functions of a complex number. Now let us see the relation between hyperbolic and circular functions. So here sin theta is equal to e power I theta minus e power minus I theta by 2i, whereas cos theta is equal to e power I theta plus e power minus I theta by 2. Since sin ix is equal to I sin hx, whereas cos ix is equal to cos hx, tan ix is equal to I tan hx. These are the three important relations between hyperbolic and circular functions of a complex variable. Sin ix is equal to I into sin hx, cos ix is equal to cos hx, tan ix is equal to I into tan hx. We have to remember these three relations. Now let us see the real and imaginary parts of a circular and hyperbolic functions. Real and imaginary parts. Of circular and hyperbolic functions. So our first one is sin of x plus iy is equal to sin of a plus b ఫార్ములా లాగుంది. ఆల్రెడీ మనకి sin a plus b ఫార్ములా తెలుసు. sin a cos b plus cos a sin b, that is sin x cos iy plus cos x sin iy, that is sin a cos b. In place of a we are having x, in place of b we are having iy. Therefore sin a cos b plus cos a sin b. It can also be written as sin x cos iy. ఇంతకు ముందే మనం డిస్కస్ చేసుకున్నాం రిలేషన్ బిట్వీన్ హైపర్బోలిక్ అండ్ సర్క్యులర్ ఫంక్షన్స్లో. కాస్ ఐఎక్స్ని మనం కాస్ హెచ్ఎక్స్ రాసాం, అట్లనే కాస్ ఐవైని కాస్ హెచ్వై రాయొచ్చు. ప్లస్ కాస్ ఎక్స్ sin iy can be written as I sin hx, I sin hx. So like this we can derive 4 formulas related to our trigonometry. Similarly cos a plus b, cos a plus b formula is cos a cos b minus sin a sin b. So in place of a x undi, in place of b iy undi. So cos a cos b minus sin a sin b. But cos x into cos iy is cos hy minus sin x into sin iy is I sin hy. So like this we can derive all the four formulas for sin a plus b, sin a minus b, cos a plus b, cos a minus b by using the relation between hyperbolic and circular functions of a complex variable. So this is all about the concept related to complex numbers. So by this we have completed our total concept of complex numbers. In the next class we will discuss our exercise questions and some solved examples. So first of all you have to practice or by heart the whole concept of complex numbers so that you can easily simplify the questions in your exercise. So by this we have ended up our class. Thank you all. Thank you.